Okay, this is the last thing we have to do for this section, which is some practice questions. And just remember, when we do topics such as algebra and geometry, we will use sets to solve problems related to those as well. All right, so let's start with the first one. Which of the following is the universal set if the sets under consideration are all natural numbers less than 10? Less than 10, B. If A is equal to 1, 2, 3 and B is equal to 3, 4, 5, what is A intersect B? We're looking for commons, so 3 in common to both of them, so this answer is C. What is the complement of set A if A is equal to 2, 4, and the universal set is 1, 2, 3, 4, 5? So if I'm having 2 and 4 belonging to A, then 1, 3, and 5 should belong to the complement. Which of the following represents the union of sets A and B when A is equal to AB and B is equal to BC? The union is just the combination without repetition. So we have A, we have B, and then we have C. So answer this one. If A is 1, 2, B is 3, 4, and C is 1, 2, 3, 4, which of the following is true? A intersect B is C. Well, A intersect B has nothing in common, so it cannot be equal to C. A union B is equal to C. A union B is equal to 1, 2, 3, 4. And equal to means that they have to have the exact same elements. And we can see that C also has the elements 1, 2, 3, and 4. So therefore, these two sets are equal to each other. Answer B. Let's check the others. A equals C? No, A is not equal to C. A has 1 and 2. C has 1, 2, 3, and 4. They don't have the same elements. B is a subset of A. B is not a subset of A because none of the elements in B belongs to A. The number of subsets of a set with 3 elements, and the formula is 2 to the n, which is 2 to the third power, and that is 2 times 2 times 2, which is 8. So the answer is D. Which set notation represents the set of all even numbers between 1 and 9? So we're not including 1 and 9, and we're only looking at the even numbers. So we have 2, 4, 6, and 8. The answer is A. Which of the following is the intersection of sets P? So P is the set of X such that, let me just write that out. So the open curly brace, the set of X such that X is a prime number less than 10. Let me list the prime numbers less than 10. So we have 2, 3, 5, and 7. Those are the prime numbers less than 10. The set of X such that X is an odd number less than 10. Odd numbers. 1, 3, 5, 7, 9. And we're looking for the intersection of these two sets. Well, we can see 3, 5, and 7 in common to both of them. So that answer is C. What does the empty set represent in a Venn diagram? A set with one element, a set with no elements, a set with infinite elements, and a set with 2 elements. The answer is B. Empty set has no elements. Which of the following is not a subset of 1, 2, 3? So the subset of 1, 2, 3 are as follows. First, the empty set, then the set 1, 2, 3, and then we have the set 1, 2, 1, 3, and then 2, 3, and then we have the set 1, 2, 3. So those are all the sets that you can have in this. All right, and we can see right away 1 is an answer, 4 is not an answer, 2, 3 is an answer, and then 1, 2, 3 is also an answer. 4 is not a subset of 1, 2, 3. Now we have some structured questions. Given the sets A is equal to 2, 4, 6, B is equal to 4, 6, 8, and C is equal to 6, 8, 10, find the intersection of A and B, determine A union C, and then use a Venn diagram to represent the sets A, B, C, and clearly indicate the intersections. Okay, let's do this on a sheet of paper now. All right, so we know that A is equal to 2, 4, 6. B is equal to 4, 6, 8. C is equal to 6, 8, 10. So we're looking at first A intersect B. Well, that means we're looking for the common of A and B. So I'm seeing 4 and 6 in common to both A and B. So then that means this answer here is 4, 6. Let's do part 2. Well, this is part A. Then we have B. And it says determine A union C. A union C. A union C is the combination without repetition. So we have 2, 4, 6, 8, and 10. That's A union C. Then we need to draw a Venn diagram to establish the relationships. Okay, so this one, let's try and draw the Venn diagram to show the relationship between the 3 sets. Now, we can see right away that these sets have 6 in common to all of them. So we have to draw an intersecting diagram. So this diagram clearly indicates that we have 2 by itself in the A, then 4 in common to A and B, 6 in common to all of them, 8 in common to just simply B and C, and 10 in C only. There's nothing in between A and C. All right, let's go on to the other one. Consider the universal set U, which is this, and the sets X and Y, and we're asked to find the union, the complement, and prove that X and Y are disjoint sets using a Venn diagram. First thing we do is we write out the sets. So let's start. X union Y would be equal to the combination of X and Y without repetition. Then B, we're asked to find X complement, which is everything outside of X. So we simply cross out whatever is in the universal set. 2, 4, 6, and 8. Notice we have 2, 4, 6, and 8 here. Cross those out already. And that leaves us with the remaining 1, 3, 5, 7, 9. And we can see right away that is exactly what we have here. Let's see the last one, which is to prove it with a Venn diagram. Drawing the sets. So as you can see, there's nothing in common to both of these sets, so therefore these sets are disjoint sets. Final question. A school has 50 students, 30 students take math, 20 students take biology, and 10 students take both math and biology. Use the inclusion-exclusion principle to find how many students take either math or biology. In other words, we're looking for the union. Then how many students do not take any of the two subjects, and illustrate your answer using a Venn diagram. So the first thing we want to do is recognize that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. Or we can just simply say the cardinality of A union B is equal to the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. A school has 50 students, so that means the cardinality of the universal set would be equal to 50. Then 30 students take mathematics, so the number of students in A would be equal to 30. 20 students take biology, so the number of students who take biology would be equal to 20. And 10 students take both, and the number of students who take both, that would be A intersect B, would be equal to 10. All right, so then we're supposed to find out how many takes either or. This is the union. So we say an N of A union B would be equal to 30 plus 20 minus 10, which means we get 50 minus 10, which is 40. So 40 students take either or. Then part B, how many students do not take any of the two subjects? Then that means we're simply going to say that if A union B is 40, and I should say the cardinality of A union B is equal to 40, then students who take neither would be equal to, well, is given by the cardinality of the universal set minus the cardinality of A union B, which is 50 minus 40, which means 10 take neither. So let's do a Venn diagram. Okay, in common to both intersection, there's a 10 here. Then we have 30 take A, so we already have 10 inside of here, that means 20 is here. Then we see 20 takes B, so 20 minus 10 will be 10 inside of here. And then we outside here now, and we know that outside is 10. And we can see 10, 20, 30, and 20, 50. You get your universal set amount. And that's it for all of the problems. If you have any questions, comments, issues, please let me know, and I will get back to you as soon as I can.